Hi there, and welcome to this lesson. In this lesson, we'd be learning linear inequalities, and under linear inequalities, we'd be learning simple inequalities. Now, as the lesson progresses, if you have any issues at all, anything comes of us unclear, please feel free to get in touch. Okay, we would be more than happy to help. Okay, let's jump right into the lesson. So, linear inequalities, simple inequalities. Now, what are linear inequalities? Now, linear inequalities are just like very similar to linear equations. Okay, they're quite similar to linear equations. They, however, contain these signs. Okay, so we have less than, greater than, less than or equal to, or greater than or equal to in place of the equal sign. Okay, so we have something like this. We have x is less than 4. Basically, this is just values less than 4. So x represents values less than 4, i.e. 3, 2, 1, 0, minus 1, 3.99999, just pretty much every number less than 4. You could also have y is greater than minus 7. Okay, the sign denotes y is greater than minus 7. If you do have any problems with the sign, basically you look at the sign, the bigger part of the line, the sign is pointing towards y. It tells you y is greater than minus 7. The pin point for x is less than 4. The pin point, the shorter point of the sign, is pointing towards x, so we have that x is less than 4. Just a small trick so you can always tell the difference. But generally, the bigger side of the sign, the wider side of the sign, is pointing towards y. So basically we have y is greater than minus 7. And then similarly, m is less than or equal to. Okay, so when you have the sign like this, written like this, you have the less than sign with a dash. It means m is less than or equal to minus 3. And then finally you have n is greater than or equal to 12. And yeah, these are linear inequalities. Now, we often require to graph linear inequalities, and for simple inequalities like this, we pretty much just represent them on a number line. For example, if we're looking to graph the linear inequality x is less than 4, we have a line like this. We have x. Okay, so it's range of values representing x, and basically we just go ahead and bring those values in, and it says x is less than 4, so we're going to draw a circle, a small circle at 4, and then we'll draw a line pointing towards the left. Okay, so it says x is less than 4, so we have values from 4, descending values from 4, basically. So you have 3, 2, 1, 0, minus 1, minus 2. So basically, graphing a linear inequality x is less than 4, you have it on a number line. You introduce a circle and you just draw an arrow pointing towards the left to show that x, the range of values in question at the moment, are values less than 4. So if you notice closely, you'd find that the circle in this case is not a solid circle, and that's relevant, but we'll find out what that is shortly. Let's do another one. So we have n. In this case, n is less than or equal to 12. Okay, and similarly we're going to plot this on a number line, and we introduce n, our values, and we have 12. Okay, so we introduce our circle there. We have 12 and we have a line pointing to the right, and basically this tells you we're talking about values greater than 12. So n is greater than 12, not less than. N is greater than 12, so we have our arrow pointing to the right, and basically it's covering values 13, 14, 15, 16, 17, 18, 19, and so on. And something very important you'd notice here is the circle in this case is a solid circle. Now the reason for this is we have n is greater than or equal to 12, and what that solid circle tells you is that you actually have 12. 12 is a part of this range, so it pinpoints on 12, the solid circle. Just think of it as solid circle tells you that 12 is a part of this range, and hollow circle tells you the number is not a part of this range. For example, you had x is less than 4. You have all values leading up to 4, but not including 4. Okay, but for n is greater or equal to 12, you have a solid circle telling you that, oh yes, 12 is actually part of this range of values, and you have 12, 13, 14, 15, and so on. And yeah, that's pretty much what we need to know about graphing linear inequalities. Now let's talk about solving linear inequalities. And solving linear inequalities is actually quite simple. Okay, no different from solving a simple linear equation. For example, you could have a minus 3 is greater than 5. Okay, pay very little attention to the greater than, just think of it as an equal sign. All right, and just solve the equation as you would a simple, solve the inequality as you would a simple linear equation. So we have a minus 3 is greater than 5, and we just move minus 3 over to the right, it becomes plus 3, and we have a is greater than 5 plus 3, we have a is greater than 8. Very simple. Okay, so solving linear inequalities no different from solving linear equations. There's one difference though, one small difference. We'll find that out later. Let's solve a few examples now. So example 1, and example 1 says solve the inequality 4 multiplying a plus 6b less than 24 plus 4b and represent it on a graph. Okay, so we have this linear inequality, and like I said, similar to solving a linear equation, no difference really, and we just go ahead and do that. The first thing we want to do is we want to expand what we have in the bracket there. So we have 4 plus 24b less than 24 plus 4b. Okay, and then we're going to move our terms around. Like I said, pay little attention to the inequality sign there, just think of it as an equal sign and solve the question as you would a simple linear equation. So we'll move our b terms over to the left, so we'll move 4b over to the left and 4 to the right, and what we have in the end is we have 24b minus 4b is less than 24 minus 4. Okay, and then if you solve that out, 24b minus 4b would give you 20b, and 24 minus 4 would give you 20. Now we have 20b less than 20. Just like you would for a linear equation, we're going to divide both sides by 20, and what we have in the end is we have b is less than 1. Simple. Now we just go ahead and graph that. So we have b is less than 1. We're going to plot it on this number line. So we have b, we introduce our values. B is less than 1. We're going to look for 1, and we're going to draw a hollow circle. Okay, because it's a b is less than 1, our range of values does not include 1. Okay, and then basically a hollow circle there, and we have an arrow pointing to the left. Okay, basically saying that the range of the values in question at the moment, values we're talking about, b is less than 1 and numbers less than 1. So numbers going towards the left of the number line, 0, minus 1, minus 2, minus 3, and so on. Okay, so yeah, let's do another example. Now, example 2. And example 2 says solve the linear inequality minus r of minus 5 multiplying r plus 6 greater than minus 18 and represent it on a graph. Now, like I said, no different from solving a simple linear equation. Okay, pay very little attention to the sign there and just work this as you would a simple linear equation. So the first thing we want to do is we want to expand what we have in the bracket there, and we have minus r minus 5r minus 30 less than minus 18, and then we move minus 30 over to the right, and what we have is we have minus r minus 5r less than minus 18. Minus 30 becomes plus 30, and we end up with minus 6r less than 12. Okay, so now we have minus 6r less than 12 is less than 12, and we're just going to go ahead and divide both sides by minus 6. Okay, so we have dividing both sides by -6, we end up with r is greater than -2. Did you notice something? Okay, something happened there. Basically, we had -6r less than 12. Okay, and then we ended up with r, we divided both sides by -6, and we ended up with r greater than -2. Now, I told you there is a small difference, a small, very small, tiny difference between solving linear inequalities and equations. And that difference is the fact that whenever you divide both sides by a negative number, okay, if you divide by a positive number, nothing happens. But if you ever faced with a question and you're dividing both sides of the inequality with a negative number, the inequality changes. Okay, so if you had less than becomes greater than. Less than or equals to, less than or equal to becomes greater than or equal to, greater than or equal to becomes less than. So basically the sign just changes to the opposite version of that sign. So in this case we had -6r less than 12, and basically divided both sides by a negative number, -6, and what we ended up with r greater than -2. And now we're just going to go ahead and plot that on a graph. So we have r is greater than -2, we have a line here, we have r, and basically we have our numbers, and we're just going to go for -2, and we have r is greater than. Okay, so we're going with a hollow circle in this case, and basically we have the circle, we have our arrow pointing to the right. Okay, so pointing to the right, showing that our values in this case, our value is greater than -2, i.e. -1, 0, 1, 2, 3, 4, and on. So yeah, I have one final example, example 3. And example 3 says solve the inequality. Now this looks interesting. Okay, so solve the inequality is 6 plus x over 12 greater than or equal to 1 over 3, and represent it on a graph. Now, simple, just the regular, and basically we have that, and we just go ahead like you would in a linear equation, cross multiply. Okay, so you cross multiply, you have 3 multiplying 6 minus x greater than 12. Okay, so you have 12 times 1, 12, and you expand the information you have in the bracket there. So 3 multiplying 6 minus x would give you 18 minus 3x greater than 12. And basically if you move your terms, you have 18, you move 18 over to the right, it becomes -18, and you should end up with -3x greater than or equal to -6. So we have -3x greater than or equal to -6. We're going to have to divide by -3. Okay, and when we divide by -3, like I said in the previous example, the sign would change. Okay, so you have -3x greater than or equal to -6, and you end up with x as less than or equal to 2. And we're just going to go ahead and represent that on the graph. So we have x is less than or equal to 2, and we have our number line here, we have x, we introduce our points, and we have 2, and we're going to be working with a solid circle indicating that 2 is actually part of our set of values. And because x is equal to, less than or equal to 2, so we have a solid circle there showing that 2 is part of our set of values, and we're going to have an arrow pointing to the left, okay, showing that the numbers are numbers smaller, the numbers in the set are numbers smaller, less than 2, basically. So you have 1, 0, -1, -2, -3, -4, -5, and so on. So yeah, and that will bring us to the end of this lesson. Very simple lesson, linear inequalities. Like I said, no different from solving linear equations, just one simple difference. Anytime you divide both sides by a negative number, the sign will change. You just keep that in mind and go ahead and solve like you would a simple linear equation, and I think you would not have any problems at all solving linear inequalities. And yeah, bye for now.